Okay. So the Chapter 22 business meeting is called to order. No minutes from September. We will try to have those at our November meeting. Treasurer's report, Gary.
Sure. We had no expenditures this month. Our only debits or payouts were for our ability to process credit cards, the monthly fee. That's it.
Okay. Who would like to make a motion to accept Gary's report? Chapter 22 member, please, and state your name.
Dean Leeson.
Dean. Who would like to second that?
Peters.
All in favor, say aye.
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 Opposed, say nay. Okay. Frequency coordination and certification, Gary.
Nothing to report on either one.
It's going to be a quick meeting.
All in favor?
Does anybody have any other old business they'd like to discuss? Going, gone. Looking ahead, our next two meetings will be November 17th and December 15th. I do not have presentations scheduled yet. If anybody knows of anybody that would like to present or have any ideas for presentations, then please let me know. I'll probably start working on that.
Yeah, Tom, call me tomorrow if you wish to discuss that.
Okay. I know Jim Peck, you said you were looking too, so I appreciate anything anybody can come up with. I do have some lined up, but nobody seems available November or December, so I think we'll be in good shape for January on forward. On Saturday, the 25th of September, Roy Taylor's family had a little get-together at the 10-Pin Bowling Alley in Chittenango to remember Roy. It was a private event, but they did invite me and Vinny, and we attended, and I had a plaque made up, but we presented to the family. I don't know if they hung it in the bowling alley. I told them they could do what they wish with it. If they wanted to hang it in the bowling alley or take it home, it was up to them. But we did do a plaque from the chapter in memory of Roy, and the picture of it is there. Here are some notes from our executive director, Jim Ragsdale. He talked about the Ennis workshop that's coming up this weekend in Atlanta. There's still time to register if you're interested, but getting a flight now might be difficult. If you'd like to bring an Ennis workshop to your area, go to the national website and you can find information there on how to do that. These are upcoming webinars. There's one tomorrow, SIP Module 2, Service and Troubleshooting Techniques for Voice over IP. And then there's one more in October, 2 in November, one scheduled in December. See all the information there. Go to the SBE.org website and look under the webinar section. And Jim reminded everybody to become SBE certified. If you'd like to take an exam, the next one available is February 4th through 14th. You must submit your application by December 31st of this year. We'll talk about the expo quickly. I did send the contract over to Gary, Kevin, and Vinny yesterday, the proposed contract for them to look over. I know Vinny forwarded it on to Chris Imlay at National today to have the legal team look at it. There's just a couple of things on there that I was concerned about, but probably not a whole lot we can do about. The standard language in past contracts as well. So we'll probably be signing that soon, sending a deposit to lock in, make sure we're good for our show on Wednesday, September 28th, Thursday, September 29th, with National holding their fall meeting starting on the 28th and our expo on the 29th. I have done a lot of updates on the website for the expo. There's still more to do. Working in that, it's in progress, and we will start up some meetings probably after the holidays. We'll start meeting about the expo and doing some planning. And if you'd like to join that team, please contact me. There's my email address there. Most of you have it, and you can find it on the website anyways. So does anybody else have any other new business they'd like to discuss, or anything going on in their place of business they'd like to talk about? If not, I'll make a motion to close the Chapter 22 business meeting. Would anybody like to second that?
George, well, Kurt.
Okay, all in favor?
Aye.
Opposed? Say nay. Okay, we'll move forward. I just let Lou Volino, and he's probably been sitting there for a while. Open discussion outside the business meeting. Is there anything anybody would like to discuss? Anybody from any other chapters? If not, we'll turn things over to Steve Holmes. And thank you for coming out and presenting tonight. We appreciate it. And I will look forward to your presentation. And I will get my stuff off the screen here for you, and you can share your screen.
Sounds good.
Let's see, I gotta get the right computer. It's not coming up there. Stop share. Okay, you should be able to share yours. And Joe Castellano is with us tonight too, the sales rep for Leader that contacted me to arrange this meeting tonight. I want to thank both of you guys for doing this for us tonight.
Thank you guys
Everybody
for
can
having
mute
us.
their mics,
Appreciate
it would help.
Yep. Okay. So the presentation today is looking at what needs to take place in a hybrid SDI IP world for folks that are moving into IP from SDI and are still going to have a little bit of SDI or a lot of SDI, a little bit of IP still running, and what you need to know for just normal everyday day-to-day operations, not necessarily from an engineering perspective, but from a day-to-day monitoring type perspective. So the biggest thing you need to take away from all of this is you got to remember that IP is just another I/O interface. It's just another way to get video, audio, and data to or from a switch. And instead of it being a SDI crosspoint router, it in most cases happens to be an IP switch, either something like a Cisco or Arista actual data switch. It's just how we do that and what you need to know that has changed in going through this. So a lot of things go into the migration path going into IP. So people are learning this. In most cases, it's being moved into in a very slow manner. People are starting either greenfields or they're just putting pieces of their plant into IP. A lot of places are possibly switching some of their core routing to IP, but the ends are still SDI. So the unique thing with IP is it's an asynchronous transport layer, but our video is synchronous. So we end up putting synchronous data across an asynchronous network. And that has a couple of challenges that present themselves to us in going through all this. So we need to be mindful of the different formats and how we look at this, just like we look at SDI and the things we do with SDI in going through this. PTP ends up playing a big part. I'm not going to talk about it a lot in this piece. I can come back and do presentations on that if you guys would like to know about it. But PTP is the new timing. It's the new black burst and tri-level of the IP domain. And the biggest thing with PTP is we need to make sure that everything you're doing in your 2110 network is perfectly in sync with everything you're doing within your SDI network, so that you can go in and out and switch between those just like we do SDI, and it's seamless. So we need to be able to make meaningful comparisons between our SDI signals and our IP signals as we go through all of this. So the unique thing about all of this is, we're used to SDI where we've got video, audio, and data all on the same line. You plug in one thing, you've got everything. You've got your audio, you've got your ANT's data, you've got your video, and it's all coming to you. But with IP, they have broken it down to individual segments. We're going to send the video as an IP data flow. We're going to send the horizontal information, i.e. the audio that we've embedded in the horizontal information, as a IP data flow. We're going to send the horizontal or the VANC data as an IP signal flow. So all of the things that we used to have together in that one connector for SDI is still going to be most likely on one connector. It's still going to be on the same IP pipe, but it's going to be 3 different IP flows as part of the 2110 protocol stack. So we've got 2110-20, which is our video. I just noticed this is a screwed up slide. 2110-30, which is our audio, and then 2110-40, which is our data going through this. So we've got our data going through all of this, and what we end up with is a multicast transmission that sends our video payload, a separate multicast transmission path that is our -30 for our audio, and a separate multicast transmission that is our -40, which is going to be your captions, your time code, any other data that we would have stuffed in the vertical blanking interval. When we started out, before we went into SDI, if you think about it, back in the analog days, we could just take and hang an O-scope on the coax, and we could actually view the video, just direct, straight off the coax. When we made the transition into SDI, we had to be able to take the 10 bits of data that make up a pixel and be able to put those together and put the pixels next to together to each other and put them on the screen line by line and actually have a digital analog converter so that we could actually see this still as a waveform, so we knew what it was that was being represented. So we could actually check levels, we could check timing. The same thing with the audio. In the analog audio world, we could put an O-scope on it and we could actually see the waveform. Well, we had to come up with a way to be able to grab the data out of the horizontal interval, which is time compressed, untime compress that, and be able to expand that across the entire horizontal line worth of data and actually make an analog waveform back out of it, so we could actually look at it as audio bars. So with SDI, it allowed us to carry the audio and the captions and several other things within the data. But now we've taken that and moved everything around, and we're going to put this back out as 3 independent multicasts. And we need to be able to look at those multicasts and make sure that we have everything, and one of the multicasts hasn't gotten dropped, or data within that multicast hasn't gone away or gotten dropped. So things that we need to think about are IP troubleshooting. We need a deep set of tools for the engineer to be able to look at the IP layer, to be able to look at IP status. What are we logged on to? What flows are coming to me? Are they the correct flows? We need to be able to look at packet jitter. We need to be able to look at the PTP timing and buffers. And if you're doing the 2022-7, which is the one-for-one protection switching, and a whole bunch more. But that's the engineering aspect of it. That's not the day-to-day operations of looking at this data. So what we need to be able to do for day-to-day operations is be able to look at it as we've looked at our SDI forever. We need to be able to check waveforms. We need to be able to check vector scope. We need to be able to check captions, SCTE triggers, audio loudness. We need to be able to compare that the IP feed has everything the SDI feed had in it, and nothing has gotten moved, dropped, or truncated somehow in going through all of this. Yes, there is a whole set of engineering tool sets that are there for the engineer when something breaks, but for the day-to-day operator who's going to be using this and monitoring all of this, we've got to keep it with normal tool sets and be able to look at this for day-to-day operations. And then if something isn't right, they're going to notify engineering that will use the deep tool sets. We need to be able to take our SDI data that's coming in, that's most likely going to get converted to IP, and be able to see it side by side with the IP that's coming in on the same screen. So if you look here, you can see that the waveform's there, the picture's there, the vector scope's there. The bottom corner of the left side is the ANTS data for the SDI piece, and you'll notice that the bottom right corner looks a little bit different than what it does next to the vector scope over on the left side, because that's the IP data coming in. We can separate out the looking at CRC and timing checks for all of the pieces of SDI, and then look at all of the pieces for the IP sitting right next to it. So we can have different status measurements up for each one of the respective transport mechanisms. The other thing is to be able to take the screen and customize it to how you would like to be able to view things. In this case, I took and put the waveform on the left-hand side, put an ANTS data list kind of down the middle of the screen, looking to make sure my VITSI is there, my payload ID, my 352 payload ID is there, and my 608, 708 captions are coming through the screen. And then be able to see my vector scope and my picture with the captions on it to make sure what I've got, and be able to switch this and look at this in the SDI side and be able to switch it and also see it in the IP side. So one of the unique things about the Leader waveform monitor is the multi-view screen is completely user selectable. You can put what you want on it, you can drag it, you can drop it, you can size it and place it where you want for the operation and what you have and what you're doing and what your job is in this particular function. And you can customize this for work area to work area to work area to suit what you need to do. The scope also has 4 different waveform engines, so you could actually be looking at a variety of SDI and a variety of IP signals at the same time. You can look at up to 4 different inputs at one time and manage those and assign them to either IP or SDI as needed. So if you look at this, this is just a simple shot of the picture. And one of the things we always need to make sure to keep our life simple and not incur fines and have people calling our station up is make sure captions are in there. So if you look at the left-hand side here, it's looking at the SDI feed that is getting rolled to 2110, And once it got rolled to 2110, the captions were missing. Both of them are trying to look at captions, but the captions are clearly missing on the IP feed. So they are completely getting stripped out of the -40 flow, and it's very easy to see from an operator's perspective. Now, yes, this needs to get passed over to the engineering team to go find out why, but for the operator, it's very simple. It's straight on the screen. You look at it and you know what's going on. So that's the whole thing that I'm focusing on this presentation, is keeping it simple. Here, just looking at Luma waveforms, in a lot of cases at TOC, what we're looking for is making sure that the signal's coming in, the Luma's where we want it, captions are in there, and you can see on the right hand side again for the IP side, the captions again are missing in this flow. The waveform looks okay, but the captions are missing. The other thing you want to be able to switch and look at is the content advisory, VChip, to be able to look at that. You can put the VChip on the screen and VChip data is coming through for both your IP and your SDI, and it is being displayed correctly. The other thing would be being able to pull up your SCT 104 splices and be able to see those in both SDI and IP, and actually get a on-screen roll of when the splice is supposed to be there and the data for the splice, as well as be able to log all of this off. Very easily be able to put a little thumbnail down the bottom of a waveform and be able to view your SDI incoming waveform, your converted over to IP waveform, and actually see this stuff actually right next to each other. The same thing with looking at audio, to be able to put up audio and look at 4 pairs of Lizidoo for your 8 channels, your 4 pairs coming in, be able to see the Lizidoo for all 4 pairs simultaneously, and then be able to actually look at the audio bars for the incoming, then be able to switch over to be able to see the same thing looking at your IP side that's coming in at the same time, or put the 2 sets of bars right next to each other. On the left hand side is my SDI coming in, and on the right hand side is my IP. And if you look, channels are missing. In this case, the surround channels got nixed out of the flow. So these are the types of things the operator needs to be able to see easily, be able to see quickly, without having the knowledge necessarily that the engineer has, that needs to be able to go and look at all of this stuff. So if I just pop over here for a second. So right now I'm looking at my IP input. I can switch really easily over to my SDI side and see the 2 next to each other. But then I can also change the scope over to a simultaneous display, and I can then turn on the IP. So I'm looking at my SDI on my left hand side, I'm looking at my IP on the right hand side. So here's pre-encapsulation, and over on the right hand side is post-encapsulation. And you can virtually do that for the vector scope, the picture, or any scene that you want, up to actually 4 inputs. So if you were coming in SDI, getting converted to IP, going back out to SDI, you could actually have all 3 up at the same time to be able to see this and be able to make judgments. And you can turn around and switch and switch any one of the inputs on or off and be able to switch between the SDI input if you want to see it full screen, or if you want to see them both next to each other, and be able to do things like turn on captions and be able to see things. Also, the multi-display here, like I said, gives you the ability to go in here, and let me just shut off the second input to stop some of the confusion here. But you can right click, go in here to layout, and if you don't like something or you want to resize something, add something else, all you need to do is turn around and say, hey, I don't need that big a picture because it's just for confidence. I've got other monitors for it, but I like a nice larger waveform, and you can turn around and make the waveform larger, then turn around and save that, and you've just changed and saved that particular input to be there. And we can look at timing, and you can see my timing's going nuts right now because I'm looking at my SDI input, and my SDI input is coming out of a playout device that is not timed. If I take this over to my my IP side, I can see that it is timed and it is stable. It is 21 lines out, or it's actually almost 21 lines out. It's 20. It's within the window. But the thing that you'll find is that your timing for your video is going to be, because we're only sending the active portion of the video, the timing will be 21 lines out for 1080i or 42 lines out for 1080p, because it's just the active portion of the video. But PTP itself turns around and needs to be in time with where black is, so you can look at and make sure that your PTP now is perfectly in time and right on top of where your black is, so that where black is starting, PTP is also starting, so that you know your whole system is perfectly timed and you won't have any switch point errors when you're selecting either an IP source or your SDI source, or switching between the two. The other unique thing is the ability to be able to look at lip sync, because let's face it, we always run into, every time we go through an encoder or decoder or any conversion, we can easily pop up with lip flap problems. And in this case, this is looking at the SDI input, looking at 8 channels simultaneously. And on the left up here are all of the 8 channels, and they're perfectly in time. They're all 0 by 0. And then turn around and look at the IP side. Here's the audio IP input, and you can see that it is advanced, which is not where you want audio. If you got to have audio issues, you always want them slightly delayed, just because of human nature. We're used to audio being behind video, not in front of video. But in this case, they're not more than a frame out, they're just about a frame, so they're probably not noticeable. But if you've got the ability to look at it, you can turn around and dial your delay of your IP in so that it comes in within a packet. You're not going to get it probably absolutely 0, because we got to move by a packet width. So we're going to jump from one place to another place by the width of what an audio packet is in the IP stream. And this is about as close as I could pull this particular stream in. But if you're looking at it, you're only 4 milliseconds off, and 4 milliseconds, especially if it's 4 milliseconds late, you would never, ever be able to see that. But that's one of the nice things. This means that within the scope, you have to have your video and audio actually timed when they're being presented on the screen, and that being tied back to PTP so that the presentation of the audio and the presentation of the video are synced together and synced to PTP, not free running, so that you can turn around and make these measurements of looking at your SDI coming in, be able to look at the IP coming in, and then if you're going back out SDI, look at it again. And in this case, there's another little issue that this brings up. If you look back here on my SDI coming in, I had 8 channels of audio coming in. Once I hit this particular audio converter that was encapsulating my audio, it only encapsulated 4 channels. The other 4 channels, it didn't encapsulate, so I dropped 4 channels. So trying to do 5.1 plus 2 or anything else is going to be a little difficult in this case. Like I said, with the timing, because of 2110 only sending the active portion of the video here, and the active portion of the video starting 21 lines into the entire raster, entire frame here. The 0 by 0 point for black is sitting here at the beginning of the first line of VANC, and that's also where the beginning is for PTP, and we need to be able to check that our PTP also starts at the same point, and then how far out is our video. And like I said, the video RTP start point should be exactly 21 lines out, so that this point in IP and this point in SDI are perfectly in time with each other, so that when you do switch between them, you won't get any vertical or horizontal shift. Then, like I said, the PTP back to NTSC, i.e. Blackburst, should be 0 by 0, and minus 0.407 microseconds is within a packet width of looking at IP. The other thing is to be able to present the ANTS data that you want to see easily to somebody, so they can pop over to an ANTS data screen and see really easily and very quickly, yep, I've got my VTC, I've got my 352 payload ID, I've got my captions. AFD in this case is missing, but I've got the primary things that I need to be able to continue on and be able to look at it, what's coming in from my SDI, and then what was getting converted over on my IP coming here, be able to look at them at the same time and be able to see very clearly that my VTC is missing and my captions are missing. So my -40 stream that's supposed to have my ANTS data in it definitely did not come through. But like I said, make it simple, make it visible, so that the operator can look straight at it and see what's going on. And you can save all of these screens off as presets, so that it would be very easy for an operator just to pop a preset and be able to go to each one of these screens and to be able to see things. Also, to be able to look at the structure that's coming in versus what NMOS, which is the control system for switching the different IP flows, and being able to compare with the 352 payload ID little decoder ring of what the structure is of your 352 payload ID here, and look at what NMOS says my 352 should be, and come up with a issue that it got marked as interlaced, but it was actually a progressive stream, The scope was able to figure it out and display it, right? But the SDI out of the scope is going to put a new 352 in it to the next piece of gear, either the monitor or whatever you're going to feed if you're using the SDI reconstruction back out of the scope. And it's going to actually have the 352 payload ID marked wrong leaving the scope because the NMOS said it was the wrong thing. And so rather than trying to break down the NMOS SDP file, again, show it in something that is fairly normal to look at. But then when we get to looking at structure errors, like looking at CRC errors, TRS position, TRS code errors, this is where, yes, it is going to change and we are going to have differences because we're not coming over the same transport. But you can see that I've got absolutely no CRC errors, no TRS errors, no line number errors. Everybody's perfectly fine. But in my IP, the red marks here are drop packets. They're RTP sequence errors. And an RTP sequence errors is exactly like an MPEG CC error, continuity count error. It's the same exact analogy, that there is a RTP sequence number that for every packet should be incrementing by 1. And when a packet is dropped, it's going to show up and let you know that you are dropping packets. And each one of these drops will be ran off into a log file, and you can tell exactly what date, what time you actually took the hits, as well as be able to expand this logged view if you want to see them physically out to 72 hours, or get it down to the last 2 minutes and be able to look at the data coming in. So some things, yeah, we do have to view them slightly different because the transport layers are different. But most of the data we can actually look at exactly how we looked at it when we were looking at our SDI. The other thing we need to get used to a little bit is in SDI, if we took a CRC error, all we did is change the value of a single pixel. We didn't even lose the pixel. All we did was change the value of that pixel. But if we take one CRC error in an IP packet, the switch is going to throw the entire IP packet away, and that IP packet will be lost and dropped. The problem is, in IP, one IP packet is a quarter of a line of video. So you're going to turn around and throw away a quarter of a line of 1080 video. That means that every packet beneath that is going to shift up and left. So it's going to shift up by a packet, and it's going to shift left by a quarter of a packet. And every single packet from that point to the end is going to now be an error because all of the TRS markers are all in the wrong place. Every single monitor or every single device munching on this data is going to respond differently. It's all in how they build their pictures. So some of them are going to give you the shift, that quarter pixel shift from there to the bottom of the picture. Some of them are just going to get white stripes in them. Some receivers or processors are going to go absolutely black because all the TRSs are missing. So here's a picture of one display device that when the data hit right in the middle of Lady Liberty here, it actually shifted by a quarter. Here's your quarter of a line shift, and from that error point for one packet error all the way down to the bottom of the picture, everything was shifted by that quarter of a packet that was dropped. It still put the picture together, but everything was off in the wrong place. This happens so fast though that all you see is just a jumbled mess on the screen, and it comes right back. So you get that jumbled mess, and then it goes boop, boop, and comes right back. This was just a freeze frame I was actually able to grab in the middle of one. Other devices, receivers, processors, display devices may give you little white stripes at the packet losses. So this was several different packet drops throughout the picture, but you can see where the packets are missing and where the data is actually missing in that. The other one, which is actually more common, happens when you've got the shot, you take the error, and at the point of the error to the end of the picture, it's going to go completely black because it can't resolve the data because it's all in the wrong place. So if the data happened in the middle, if the drop happened in the middle of the picture, from that point to the bottom, it's going to go black. If it happened near the top of the picture, it's basically going to look like you dropped the entire frame because that one packet dropped in a quarter of a line. So the thing that we need to be very careful about is that we have absolutely zero packet loss. And that's why everybody has gone to the 2022-7, the one-for-one packet mode, where you've got your A network, your B network, red and blue, whatever you want to call them. And we take the stream out of both of those, and there's a packet picker that whichever packet comes up first, that's the one that gets grabbed and used. When there's a discontinuity and it comes up, the packet's not there in the one stream, it's in the other stream, the packet picker just grabs it out of the opposite stream, and nobody's the wiser that you're having errors. But it does present a monitoring problem because it doesn't necessarily always tell you that one of the two network flows is actually in error. This is something that needs to be improved within the network monitoring statistics of a lot of gear, is the notification that we are taking errors to the point that we actually respond to those and look at both networks and continue to monitor them. So, like I said, when you have a network and you have no packet errors, but something happens in the path from one switch to the other next switch, and you have a dropped packet, you will not see that dropped packet coming out of that switch. That switch is going to turn around and just throw that packet away. The reason IP switches throw the packet away is we don't know exactly where the error is. If it's in one of the address fields, it could completely change where the data is going to. You know, think of bank transactions. Think of your check deposit. If you dropped a packet and it changed the address field and gave your check to somebody else. So we can't have things like that happening. Or in video, you know, little Johnny's over there watching his little morning program, and all of a sudden you take a packet drop, and all of a sudden the kids channel all of a sudden changes to the woohoo channel, and Johnny goes running to mommy going, "Mommy, mommy, what's that?" You know, it's the last thing we want to have happen. So we've got to throw the packets away. So that means from there on to the end, there's absolutely no packet errors. So this is why we have to come up with a different way to monitor this. We can't look at the packet errors. We have the loss of data, and it's going to look like junk, but you're not going to see raw packet errors. This is where we need to turn around and monitor those RTP sequence errors and look at those RTP sequence errors so that when we take that data hit, we can see those RTP sequence errors travel through the system. So we still have an identifier that's still going to tell us what's wrong. And when we get back to that top switch at the top and we look at the data coming in, we'll be able to see the CRC errors of the actual IP flow coming in errored, as well as the RTP sequence errors. But in the rest of the flow, all we're ever going to see is just those RTP errors. So there's a little bit of knowledge you need to know about how the networking works to be able to track these errors and be able to see these things. So we still got the data loss, but we also have those RTP sequence errors that go through this. So we can detect that using this stuff. So, you know, just to kind of get back, the thing that I wanted to talk about here was, you know, how easy it is to be able to, you know, look at things, to be able to view, you know, just a simple waveform. And if you want to turn around and throw a picture on this waveform, you can go in and turn around, make the waveform transparent background, turn around, throw a picture on it, size that picture where you'd like it to whatever size you'd like it, drop it in the bottom corner and say save that, and now you've got a nice little thumbnail sitting at the bottom of your waveform. And every place that you switch, whether you bring in SDI or whether you turn around and bring in your SDI or your IP or look at both of them, you'll turn around and have your picture. Now you can have the pictures next to each other, which is a little confusing, or you can go in and turn around and tell them that I'd like it tiled rather than what it's called normal, and then it will put the picture over next to the waveform itself and be able to present the waveform for both what's coming in and what's going out. And you can turn around and view this. And you could do the same thing for your vector scope. You could turn around and say that you'd like a little thumbnail of what's going on, look at the layout screen, and turn around and say, okay, let's make the background transparent so it doesn't shadow the picture. Come up with the picture, make it tiled, and drop that picture in the bottom. Whoops. Oh, grab the background. Silly man. And you don't need to keep the box absolutely perfect. It's going to put a perfect 16:9 window in it. And drop that down on the bottom, whatever size you want. So it's very flexible to be able to lay this out and go through however you'd like to be able to view things and be able to look at them as what we're used to looking at as we go through this and do our day-to-day life. So, like I said, we need to be able to look at this, recreate things, be able to see them, how we're used to being able to do them, be able to see inputs side by side. We need the tools to be able to look at the timing to make sure we are locked and configured correctly, and make it simple and user configurable. So I want to thank everybody. I hope this presentation made some sense for you, and I hope if you've got any questions, more than willing to turn around and answer any of them.
Quiet group tonight. No questions. Anybody?
Silence. As some people say, it's time for a retirement.
Well, Steve, thank you very much.
Yes, just you know, some food for thought if you're moving into this stuff. Some of the things you need to look for and be able to do, because you know your operators need to be able to look at it easily. Yes, the engineering team needs to be able to dig into it, but your day-to-day operators don't need to become IP jocks. And you probably can't afford them if they were.
Joe and Steve, is it okay if we post this? We were recording this. Is it okay if we post it on our website at some point down the road?
No, certainly.
Okay.
Yeah, absolutely. We appreciate that.
I don't know how well it came out. It's the first time I've hosted the meeting and done the recording. Vinny's always handled it. I may have the screen shrinking and expanding when I admitted people into the room. I don't know. I'm getting used to it. I've always just been a participant and shared my screen for the meeting, and that's it. So.
Steve,
All right.
Dean here. Do you have any words about 12K and what's going on?
12K mean SDI? 12G SDI? Or 12, when you say 12K?
12G is what I meant to say.
Yeah, okay, 12G. Okay, I was gonna say there's 8K. We do 8K. Just, it's rather unique. There's a difference between how we handle 4K in IP and we handle 4K in SDI. So in SDI, it's still made up of 4 independent streams that each stream is got a Luma channel and a Chroma channel, so it's actually made up of 8 things that are multiplexed together. So it is a little bit of a conglomeration. The biggest issue I've seen with 12G is if you think about it and you go to the third harmonic, because you need the third harmonic of the rep rate to be able to pass the rise time of the I pattern. So you are in the middle of the microwave band. You're somewhere around 20 to 25 gigahertz of passband that you need to have. And the biggest problem I've seen has been the patch bays, when people try to use their 3G patch bays, because the patch bays do not go out to 25 to 30 gigahertz. And the ones that do are really expensive.
So are they talking to one another within the frame? Do they talk to each other because they're radiating energy out?
No, they just destroy the I pattern. The rise time just destroys the I pattern. It just knocks the rise time to death. The other issue with 12G is you're not going to find an ECO out there for 12G. Because every single switch would have to be a microwave relay switch. Those microwave relay switches are about $1,000 a pop. So, and they're huge. So to do an ECO at 12G is just ridiculous, and they're all 50 ohm, because microwaves, it's all RF, it's 50 ohms. I looked into, what it might cost to do it, and the setup to retool one of those switches to try to do 75 ohms was in the millions of dollars.
Interesting. Thank you.
Yeah, so it is something we kind of have to live with when you get into 12G, is you're not going to find an ECO out there. And, you'd have to turn around and put impedance matching pads on the front and back of a microwave switch, and you'd probably lose about 12 dB.
So, thank you.
Does anybody have anything else?
It's nice to know it's 76 degrees and partly sunny.
Somewhere.
Somewhere.
Not here.
And the only other thing I've got is go Dodgers. Any other questions from anybody? You've been awful quiet, Mr. Carl.
Hello, Steve. Nice job.
Thank you, sir. How the world are you?
Life is treating me well. Thank you.
Good, good. I am glad to hear that. Everything doing good with your boys?
Yeah, they're gainfully employed and off the payroll, so that's as good as it gets.
Sweet. Yes, it is. Yes, it is.
Both Steve and Carl and I worked in tandem at Tektronix.
For many,
Know
many
each other.
moons.
Yes, we know each other well.
So if you go to the Leader America YouTube channel, I've actually got a 3-part series that I've done for SBE chapters, actually focusing on different pieces of 2110 more from an engineering perspective than an operator perspective. And I'm more than happy and willing to provide any type of presentation you folks would need in the future.
Great, that's good to know.
It's nice seeing you, Steve.
Thank you, sir. I appreciate it. You're looking quite well, my friend.
Makeup is
Yeah, no, I got a little touch in the highlights going on here.
Well, thank you everybody for coming out. Hope to see you again next month, and we'll come up with a presentation for you and have the word out probably in the next week to 10 days.
Thank you.
Thank you, Tom. Thank you, Steve.
Yep, everybody take
Very nice
care.
presentation.
Yep.
Thank you.
Not
Steve, it's nice seeing you again.
Everybody
Yeah,
have a
everybody.
great evening.
Great to see you
Bye.
again.
Thank you.